Antimatter.
Antimatter and matter look essentially the same. Well, not essentially, completely identical.
Exactly.
So, for example, if you take a cup of tea and a cup of anti-tea, they will both look completely identical down to the very atoms. Indistinguishable. It's what's inside the atoms that actually vary.
It's inside the atoms which is the difference that makes it between antimatter and matter. In a normal cup of tea, the hydrogen in the tea has electrons and protons. Now the electrons have a negative charge and the protons have a positive charge. However, in the anti-tea, we see the opposite. Exactly. The electrons have the positive charge and the other thing, proton, has the negative charge.
So the protons would become anti-protons and the electrons would become anti-electrons, known as positrons.
Yes, and the charges are reversed. Our understanding of the Big Bang implies that when the Big Bang happened, an equal amount of matter and antimatter were created at the same time. But we look in the universe and we can't find any antimatter.
Now, scientists at CERN have recreated miniature Big Bangs and discovered the same exact amount of matter and antimatter, which means that our amount of matter and antimatter from our Big Bang that created the universe should be in perfect balance. But it's not. I don't know. Don't say that bit.
Clear off!
They don't tell me that bit.
Because matter and antimatter have opposite charges, it means that if we pour our anti-tea into our tea, they would cancel each other out. Now, it would taste. In the dense beginnings of the universe, there were many collisions between the particles, but that doesn't explain the imbalance between the mass amount of matter and the virtually no antimatter.
Is it possible that perhaps the universe started off with so much more matter than antimatter? Hence, the resulting collisions essentially meant the deficit between the amounts stayed the same.
Okay, so how about, right, when the universe began in the Big Bang, loads of matter flew over to our side of the universe, and all the antimatter flew over to that side of the universe where we can't actually get it.
But if that was the case, we'd see gamma rays from that side of the universe. That's how gamma rays were created.
Well, so
gamma is given off when matter and antimatter collide.
But we see nothing.
But we see nothing. So that kind of ruins that.
It does.
Bang! I'm going to hit you with a new theory.
Yeah. So our suggestion is that when matter and antimatter collide, everything's eliminated apart from a little bit is left over.
So, for example, you take your tea and your anti-tea and you pour them into the same cup together, and everything gets wiped out except these few tiny dregs at the bottom, which is supposedly the universe we're in, by this theory. Beep beep. Cut.